Okay, Assalamualaikum warahmatullahi and a very good day to everybody. So we are going to continue our lectures on the new topics today. So we are going to start to play with the hardware. Actually, previously you are playing with the LED, and right now you are going to play more on the hardware related to micro C, which is going to be the motors. Okay, so for the introductions, we are going to touch three types of motor. Okay, the first one, they call it DC motor. The first one they call it DC motor. Okay, right. The first one is DC motor, and the second one they call it stepper motor. This is the first one. This is the second one, stepper motor they call it. And the third one they call it servo motor. So these three motors will be covered in our lectures in this semester. So to control all of these, got different types of methods. So you have to understand the concept of the motor, because these motor are not the same. So it based on what applications that you want to use. Okay, for example, DC motor possibly that you can use for the mobile robot. For example, that you have a robot here, then this is the wheels here. This is probably a DC motor. Stepper motor is something as like stepping motor, so that's one maybe more accurate on the angle readings. And the last one is servo motor. This is going to be covered in the next two chapters. Okay, let's start for the DC motor here. So in this DC motor, what you're going to learn is to identify the concept of DC motor, able to write the DC motor programming with PWM concept. PWM is pulse with modulation. Okay, and the last one, that's very important one, another IC that you're going to learn today is the first one. Before the main one you are going to we have learned so far is about PIC 16F, right? So this is to understand the H bridge. H bridge is another IC. We call it L293D. This is a driver. They call it a driver to the motor, or I call it H bridge. Okay, that is the concept for this lecture. That is the objective for this round. Okay, let's move on. So what is all about DC motor? If you go back to your secondary school, maybe you learn about this theoretical behind of how the DC motor works by having the magnet field over here, and then you start to give power supply, then you start to turn around based on the thumbs, rule of the thumbs. So here is the one that we are going to play for this type of DC motor example. This is the one. So if you can see that this is the DC motor, it has two connections only, this one and this one. So it's very easy. So if you put 5 volt here, like a battery, right? Another one is ground. So the motor will turn to one direction. So if you swap the values, here is ground and the next one is 5 volt. So it means that the directions of the motor will be turned at the opposite here. So it's very easy. As long as you give a power supply and the ground, the motor will work. As long as this motor can be working, can works with only 5 volt supply. If for example that this motor need 12 volt power supply, then 5 volt is not enough to turn it on. So this is the concept DC motor. So once you put a 5 volt, it will turn like this. Then if we change the value, it will turn back the positions, the directions to the counter, maybe counterclockwise or clockwise. Okay, so that's the concept, right? Okay, a DC motor is an electrical motor that runs on direct current, which is this one. This is the theory. Okay, the speed of the DC motor, the speed of the rotations here. Okay, so you can see that this is the speed of the rotation. So let's try here. I'm going to have a 5 volt here. Let's say for 5 volt here. This is the rating for this motor is 5 volt, right? So for example here, this is a 5 volt motor. So I give you 5 volt and this is 0. It's going to turn as maximum speed that this motor can have. All right, this is the maximum one. So what is this statement say that the speed of the DC motor is directly proportional to the supply voltage. For example, if we reduce the supply voltage from 5 volt to 2.5, instead of 5 volt, you reduce it to 2.5, the motor will run half from its speed. So you can see that the value, the speed of the rotation will be half divided by 2. Very simple that, for example, that you have a battery 5 volt, right? So over the time, your battery is going to be decreased in terms of the power. So it can be at 2.5 volt. So the motor speed will be slower than the 5 volt input. So it's very simple. So the DC motor is directionally proportional to the supply voltage. Okay. All right. So how do you want to control a DC motor by using a PIC? So there are things that you need to understand, which is these terms and the theory behind. What they are going to use is, they call it PWM module in PIC. This is a PWM module. So this is the module in PIC. So PWM module in the 16F877A is accessed through CCP pins. They call it CCP module, which is a capture, compare, PWM. This is called CCP pins. So two PWM outputs are available from the CCP1 and CCP2 modules. So where are these modules? So for PIC16F, you have two PWM outputs available from CCP1 and CCP2. So what's the function of this PWM output? Is to give the PWM to the motor so it can rotate by different speed you give to it. So two PWM sources to external devices, which is a DC motor driver. So where are these two CCP pins modules? So you can see that, for example, this type of robot, right? It has two wheels. So this wheel is connected to a DC motor here. Another one is connected to DC motor here. So this motor will be turned to move the robot. So where is the connection? So if you can remember back, this is actually the diagram for PIC16F. So the CCP pins are multiplexed with port C. So it means that at port C you can get the CCP pins. Where is it? So CCP pins is here at port C. So here they are. So you have to use these two pins, or maybe one pin. So one pin for one motor, another pin for one motor. So one motor here, one motor here. Alright, this is, they call it CCP1 and CCP2. So the function is to give the signal of PWM. So when I say that it's giving out, so it means that once you want to use this port to give a signal as a CCP pins as a PWM, you have to set up the port C over here as the output, which is this one. You have to set up all the port C, which is this pin, which is RC1 and RC2, this pin as output. This is a must. Set as output. Okay, so that is the two pins, very important if you want to control the speed of the DC motor, for DC motor only. All right, okay, let's move on. Okay, then we are going to learn about what is the term for pulse width modulation, which is PWM. So this is PWM. So this is the theory of PWM. Okay, what is it? PWM is the modulations of the pulse width of a signal in cycle. So you can see that in a signal, there's a pulse here. So this is a period, so this is a pulse. This is a whole period. Whatever that going up, this is a pulse. Okay. So period is the time to complete one cycle. So this is one cycle. So what is it? Duty cycle. Duty cycle is this pulse. Is equivalent to duty cycle, which is the percentage of time when the signal is high. So this is, you can see that from this percentage, right? It can be maybe around, this may be 2/3, 1/3 over here. This is maybe 1/3, maybe 1/3. So if you say half of it, it can be like this. So this is all high and the rest is low. This is half of the PWM. So this is percentage, maybe around 50%. So this is around 33.3%. Right? So that is the terms that you need to understand. What is period? What is duty cycle, which is the pulse, and how do you want to calculate the duty cycle? Okay, let's move on. Example here. So what is the duty cycle just now and the period? You go back to the definition from the previous slide. So this is the example for a period given 200 microsecond and the pulse time is 50 microsecond. So it's very simple. Duty cycle is equivalent to this one divided by the whole period, right? So micro, you can take out this one. So finally you can get 25% from the whole 5 volt. Means that, let's say for example here, this is a 0 volt, right? So this is 0 volt and this is 5 volt. So if you have only this one, means that only 25% from 5 volt is around 2, I think it's around 2, is it 2.5 to 25%? 25 divided by 100 is around 1.25 volt. So you can imagine that if you are giving this type of pulse to a motor, your motor will only turn with the speed given around not the speed given. This is a 1.25 volt given, and your speed will be slower. So if you increase this to maybe half of it, right? You increase this period, the duty cycle. So it means that you're giving 2.5 volt for the motor, and the rotation will be faster. Okay, so that is the relationship between duty cycle and the period and how it works on the motor speed. So the motor speeds can be controlled by your duty cycle. Okay, so next, PWM in DC motor speed control. This is what we are talking just now. So you have this type of signal given to your DC motor. So you can see that this is a 200 microseconds and the pulse time, which is duty cycle, is around 50 microsecond. This is duty cycle. And your amplitude is 5 volt, right? So when the duty cycle is 25%, the speed of the motor is actually 25% of the full speed. So for example, your motor here is 5 volt motor, which is, this is a highest speed it can go. This is a rating 5 volt only. So this is a spec, right? So if you give 5 volt, it will rotate and have the highest speed. Okay, so if you give the duty cycles only like this, around 25% only from the full period, this is full period, right? So you actually given only 1.25 volts only to the input. So instead of 5 volt, you are only giving the motor 1.25 volts. So the rotations of the motor is slower compared to the first one just now with the 5 volt. All right, so this is the spec. You have to understand the motor speed versus this one. The motor speed, we are going to assume that the spec for this motor is 5 volt for the full speed rotation. Okay, if you want to have another analogy, which is can be tested also at LED. So example here, right? So this is your PWM. So this is your duty cycle. So this is the whole period here. This is same period, right? Sorry, sorry. Let me. So this is the period here. So this is your duty cycle. Same goes to here, 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 here. You can see that the duty cycle is getting bigger and bigger, right? So this is around 50%. This is around 50%. So you can see that this is 100%, means the whole period is actually full. So if you give these signals to the LED, you can see that this is the connection. And this is RC2, which is just now the CCP pins, right? This is CCP pins number 2. If you give these signals out, you can see that your LED is going to be dimmer for the lower duty cycle given, and brighter if you give higher duty cycles to it. So this is the concept, very simple. This is just like a motor again. So you want to see the value, the results for it. Okay, so the duty cycle is the one controlling the speed of the motor. Okay, so this is how you want to do the calculations of the PWM period. Okay, so three values are given, three parameters needed to be used to calculate the period of the PWM. Okay, the values are, the first one is they call it PR2 register, which is a register name, which is PR2. The second one, they call it timer 2 prescale value. This is a value. And the last one is oscillations for the clock here, for the oscillation. The oscillation. So PR2 is 8-bit registers. If you go back to your RAM, you can try to find this name, PR2, which is a register, 8-bit size. You have the timer 2 prescale. Okay, scale the output from 1 to 1 until 1 to 16. So this is the one that you need to get the value. This is by ratio. And then the T oscillator, this is the clock oscillator, which is the frequency. Okay, so this is a formula. To calculate the period here, so this is a formula. PR2 plus 1 times 4 times T oscillation times timer 2 prescale value. So you can get finally the period of the PWM. Okay, example here. Given PR2 is 225, T oscillation is 1 over 20 megahertz. Timer 2 prescale is 1 over 4. So this is the timer 2 value. Okay, so PWM for this period T, PWM PR2 plus 1, which is 255 plus 1 times 4 times 1 over 20, which is T oscillation megahertz times 4 for the timer 2 prescale value. So you can get the period of the PWM is at 204.8 microseconds. Okay, so if you divide this number by 1 over this number, you can get the frequency of the PWM. Okay, so this is an example of table PWM frequencies and resolutions at 20 megahertz. Okay, so let's have a quick example here. Let's try to calculate here. Is it correct or not by having this formula? The value can get the PWM frequency we can get from here. Is it match or not? So now we know that PR2 is this value, FF. FF is going to be 255. And the timer 2 prescale value is 16. So you just can go for the formula here. So PR2 plus 1 is 255 plus 1 times 4 times oscillation of the clock. This is given at 20 megahertz. So 1 over 20 mega sorry. So 1 over 20 megahertz 1 over 20 megahertz, okay, times, is it 4? So you have times 16. So what's the value here? Let me calculate. 256 times 4 divided by 20 megahertz times 16. The value is 8192 times 10 to the power negative 4. So you divide this number to 1 over this number, you can get the frequency. Okay, this is 1 over t, 1 over answer. You can get finally the answer F is equivalent to this one, 1.22 kilohertz. So you can try this number, it match by using this formula. Okay, so this is how to calculate the PWM period. Okay, let's move on. The next one is a PWM duty cycle. Okay, so the first one just now is a how to want to calculate the PWM period. So the next one is duty cycle. So the PWM duty cycle is specified by writing to the CCP R1L register and to the CCP1 con bit 5 and 4, which is going to be up to 10-bit resolution. So you can see that here, this is the RAM where your register name is CCP1RL, this one. And then this is 8-bit register. This is a 0. This is 1, 2, 3, 4, 5, 6, 7, 8 bit plus another 2 here. This is going to be 9, 10. That's why they call it 10-bit resolution. Okay, so the CCP R1L contains the 8 MSBs, which is going to be this number first. So you have to insert this value. Okay, this 10-bit value is presented by this one. Another 2-bit is by this one. So thus the PWM duty cycle in time is going to be calculated like this. PWM duty cycle is equivalent to this value, which is this value from here plus these 2 times T oscillations and timer 2 prescale value. So you are going to get the duty cycle by having this value. 10 bits mean you have to know what's the value over here. For example, it puts over here 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. So you have to convert this value to decimal, and then you can put over here what's the value, right? We are going to have this value only for the duty cycle. All right, let's move on. So then the third thing you need to just understand is about the PWM resolution, which is the bits, how many resolution that it can has. So PWM resolution is defined as the maximum number of pulses that you can pack into a PWM period. Okay, this is a solution, the meaning of PWM resolution. So PWM resolution calculation up to only 10 bits only. Okay, so this is a calculation for 20 megahertz oscillation. The FPWM is given like this, and you have to put all this value over here. This is the one, this is 20 megahertz, and this is actually 4980, and then you can do this log, got the answer, then that is the bit. The answer is 11.96 for the resolution, but you can up to only 10 bits. So here you can try to play with the number also. Just now we have the example before, so try to have the formula here by having this value. So you have the PR2, you have the timer prescale. This is a log FOC of the PWM 4980 Hertz. So we are going to have this one based on this one. So check this one. Okay, so there are three things just now. The first one is a period, and then you have the duty, and the last one is the PWM resolution. Okay, the old time, you have to do a lot of things if you want to set up a PWM. This is the whole steps. Okay, you have to set up this one, you have to set up this one, the value here, declare this one, set timer to prescale, configure. This is the whole process. Manually, you have to write in your code to set up a PWM operation like this. So it's long. You have to do here, you have to do here, you have to do here. So right now, we are not going to do like this because when you use micro C, it has its own library. It's much simple library. But you need to know and understand how to use the library itself. Okay, so this is the process so far to create the PWM. And remember that why the PWM is very important, because the PWM is the pulse that control the speed of the motor. So for example, why this is very important, let's do something here. Let's try to imagine something. So you have a robot, right? For example, you have a robot here. You have to imagine. So you have a robot here. So this is your robot. And your robot is having two wheels. To move the robot in a uniform movement, you have to rotate this one and this one at the same speed, so it can move. So that's why you need to control the speed of the motor. So what happens if you want to turn the motor to here? This is maybe a junction, right? So let's draw your motor again. This is your motor. Then you have the this one. So you have the wheel here and the other one is wheel over here, right? So how do you want to turn to here? If you turn the motor with the same speed, it still will go directly over here. So what you need to do is you need to slow down this wheel, or maybe you stop it, and then if this is still moving, so it will turn. Correct, So after turn, then you have to turn on back this wheel, then it can move forward again. If you want to move here, take another route here, turn another one, turn right again. So you still have to stop or slower down this one, then it can turn. This one's still moving with a higher speed than this one, then it will turn to here. So if you do not pick up this speed for this one again, so it will turn like this only. So you have to turn back the speed to be the same like this one, then it can move forward. So same goes to what happens if you want to turn to right or turn to left. You need to know that from the wheel, right? From this is your wheel. How do you want to turn here and how you want to turn here? So if you turn the other direction here, this is another direction here, you can see that your motor is going to be, your robot is going to be spinning. So this is all how to imagine. This is very important. How do you want to control a motor? It's very important. Why do you need to control a motor? Okay. Okay, let's move on. Go back to the slide just now. Okay. So another thing that you need to know when you want to run and you want to control a motor, this is the one that you need to understand. This is the H bridge, or we call it the driver of the motor. Okay, so it can be a lot. It can be if you purchase it, you can see that it was already put on the board itself, all this stuff, right? But if you want to build it by yourself, this is how it builds the H bridge. This is a concept. So this is the concept of the H bridge. Okay, so H bridge circuit enable voltage to be applied across a load in either directions. Okay, so what is the importance of this H bridge is it is used to allow DC motor to run forward or backward. So this is different. Just now we are trying to control the speed of the motor, but for H bridge you are going to control the directions of the motor. For example, your motor is moving here forward, you have to use H bridge, and it wants to go backward, then you have to use this H bridge again. So this is not related to the speed. So H bridge is direction of your motor. Okay, so how does it work? So here, look at the concept here. This is the concept. So go back to this one. So you are going to connect your motor here. All right. So you are going to turn on. This is going to maybe your port BF0. This is going to be maybe your port B F1. 2 pins. So let's try to put 1 0 here. 1 and 0 here. So this is going to be turned on, this one. This is going to be turned on, right? And then this one going to be turned on, this one. So this one is turned on, so the current will go through this one. This is 0. There will be nothing here. This is also 0. There will be nothing here. Then the current will flow to this one, and your motor will move one direction here. Okay, so this is why you need to put 1 and 0 here. Let's try to change it. Your port B, this is port B F0, this is port B F1, this is 1, this is 0, this is 1. Let's try this one. Now this is 0, this is nothing, and this is 0, this is nothing. Okay, hold on. This is 0, this is nothing, and this is 1, and this is 1. So this is connected, so the current will go through this route and this route. So your motor will turn on the other directions. So you can see that here. So if you have 0 1 or 1 0, you have the counterclockwise and clockwise direction. This is the two conditions just now that we discussed. So what happens if you put all 0? If you put F1 is equivalent to 0, so this one. So it means that all 0. All zero means that it will be no current going through, so means that your motor going to be stop condition. So that is correct, this one, right? So last one, if you put all 1 1, what happened? So F1 here, F1 here is equal to 1, this is also equal to 1. So we are going to turn on all the transistors here. So means that right now the current is going here, going here, going here, and going here by opposite direction. Then you can see that your motor is going to be stalled. They call it stall. It cannot move. Okay, it cannot move. What is this? Okay, so it's going to stall, means the current is trying to move to these directions and it cannot, means that your motor is have a power but it cannot move, it stop. So this is just like a switch over here. You can see that this is simulation of it. So this is the H bridge operation. Okay, so this is a H bridge operation, very simple. So H bridge is for direction, the PWM is for the speed. Okay, so that's the operation of H bridge, and you just need to learn about how it works. Basically, you have to imagine, because there's no hardware in this current lecture, so you have to try to simulate in Proteus. So this is the PWM library that we are going to use in our class, right? This is not changed. This is going to be set duty. Okay, and this is the library that we are going to learn and use in our macro C programming. Okay, so I'm going to show you guys the tutorial on how we want to control a motor. So we are going to look that one in our next tutorial, next tutorial, which is tutorial number 2, which is on the next lecture, lecture number 2. So I'm going to split the lecture on the theory and the lectures on the Proteus and macro C programming. So to recap on this lecture, you have the concept of the DC motor, how to control it. So the pins related is, they call it CCP modules. There are 2 in PIC16F, which is CCP1 and CCP2 here. So this pin is the one that going to give you the PWM signal. And if you want to use this one, you have to set your Tri-C port for these 2 pins as the output. Then you have the terms for PWM duty cycles, and what is the function and how the PWM control the speed, and then the simulation on the LEDs, and how to calculate all this theory of the PWM and the period of calculation, the duty cycles, and the last one is resolutions of the PWM. Okay, so this is the old version on how you want to set up your PWM by writing out the program like this, but we are not going to do this one anymore. So this is a process actually how you want to set up your PWM. So we are going to skip this one. We are going to use directly the library from macro C, and you need to understand how to use and get the library from the macro C. Okay, so see you guys on the next lecture, which is continue from this lecture. Thank you very much.